I've been doing videos on different aspects of the design for the maximum season high tunnel. And today we're going to start moving forward with some actual construction and summarize the frame assembly of the high tunnel. After the groundwork has all been completed, we can begin building upwards, putting up the frame. I'll take you through assembling and erecting the high tunnel frame in block wall. Here is what we're going to build. The optimized high tunnel shape based on our sun path at 44 degrees north in South Dakota was covered in the previous video. We have 6 by 2 by 2 foot concrete blocks that will make up the north wall for the thermal mass heat storage part of the research project. We have a standard 2 by 12 baseboard treated for ground contact lumber. We've got 16 bows spaced out at 4-foot intervals. We have a hip board for attaching the film and the future roll-up vent. We have 3 purlins across the top with diagonal wind braces on all 4 corners because it gets quite windy here in South Dakota. And some of the ground stands and installation are also shown in this CAD model, but they are below grade. We'll talk about insulation later when we cover the climate battery part of the video. The posts are spaced at 4-foot spacings, except for the corner posts, which are a little bit less to make space for the boards and other framing materials. They extend 45 inches below grade to get below our frost line. The baseboard ties these pieces together and maintains the spacing of the posts as well as a solid fixturing location for polylock channel to hold the film and the insulation layers. Ground stakes are typically supplied with high tunnel kits. These are pounded directly into the soil. To increase the strength of the post, some growers will insert the ground stake into a concrete footing. This increases the load strength and pull-out strength of the stakes. However, in many jurisdictions, this will change the classification of the structure to a permanent structure, which would not be a high tunnel. An alternative that accomplishes both objectives is the ground stand. These have a plate welded to the bottom. The plate prevents wind from pulling the stands from the ground and increases the load-bearing capacity before they sink farther into the ground. A post hole can be dug with an auger and soil or gravel compacted around them, thus avoiding the permanence of concrete. After the ground stands and the baseboards were assembled, we started working on the blocks. You can see in this image all of the tubes that are part of the climate battery. We'll talk about those in some later videos. The blocks are assembled. The wall is made of concrete retaining wall blocks that are 6 foot long and 4 foot long. Each block's base was leveled and compacted. The blocks were then set end to end along a string line. No mortar or hardware is used to connect the blocks. They are all friction fit and held in place by gravity, lots of gravity. Many styles of these blocks exist. The style that was available locally had locations where the alignment features of the blocks would interfere in the corners. These features needed to be removed using a concrete saw, hammer, and chisel, so we could stack the corner blocks on top of each other. It is very important that the ground you stack these on has been very well compacted and level. We did this by driving over the soil with the tractor while the bucket was filled with soil, or in our case, concrete blocks, because we had them for weight. After the first of the topmost blocks are set in place, we test fit the first loop. Since this was a custom designed frame for our project, we need to make sure everything fits because no one else has done that before us. Here's a view of the completed wall. The blocks that we used are pretty low cost. They were only $50 a piece and sourced locally from our local concrete company that was only 6 miles away. However, they're not very consistent. These are low quality blocks made from the excess concrete from other jobs. At the end of the day, when they have to clean out the trucks, these are poured into molds, and instead of being thrown away and wasted, they make these nice blocks. That does mean that the blocks can be inconsistent, and the type of aggregate and materials made in the blocks can vary between load to load or lot to lot that you get based on what they were building that day. With all the blocks in place, the first end wall frame can be built. It is unique from the other bows, even the opposite end wall, in that it has vertical supports that will allow for the installation of an entry door. The middle bows are next. Each bow is built off camera in 2 sections on a flatbed. This maintains the flatness of the frames and made installing the hardware much easier. One end of the hoop is connected to the hinged anchor on top of the concrete blocks. Then the section farthest away from the blocks is set onto a ground stand. The top section lifted and inserted into the south tubes. Each section is held together with quarter-inch self-drilling screws. Purlins were installed to help maintain the spacing of the hoops and add rigidity to the overall structure while it's being constructed. With many of the bows in place, we can make additional adjustments to help maintain proper spacing and alignment of the bows, the ground stands, and the purlins. The final component of the frame is the door. This is a simple 36-inch right-hand exterior steel door. It had the best R value or insulation for the price of all the commercially available doors that we looked at. The frame is composed of 2 by 6 inch lumber set on 2.5 cinder blocks to keep it above the snow in the winter and up off of the ground. With all of the bows in place, additional structural items such as diagonal wind braces and horizontal channels for additional support are installed. We'll do a little fly around look at our frame here now that we have it all assembled. It looks fairly square. That's kind of nice. Next videos, we're going to talk about films for inflated coverings on the front side and something a little bit more exciting, the back side. We need to make an insulated temporary covering. This video was funded in part by USDA's South Dakota Specialty Crop Block Grant. If you enjoyed this video, make sure to leave a thumbs up and share it with your friends. I'd also love to know your thoughts. Comment down below and let's chat. And if you haven't already, be sure to subscribe for more content like this.